Hello everyone. So here we are, without wasting the time, we are going to continue with the last session what we have started, that is the interfacing of the LCD display. Am I audible? Okay,
Yes,
fine.
sir.
So yesterday we have seen the how to initialize, how to send the command, and how to write the code for this the LCD display. The program also we have read. Today we will see the actual simulation or how this is going to be work. And yesterday's PPT, just up to this point we have discussed that this is the assembly language program. If you have seen this program, you have downloaded the PPT, you might be gone through it. The same program we can write in the embedded C, that is C programming, by using that one. But we have to follow the syntax structure of the C programming for that. So that also available on the internet. So that also I have copied over here in this PPT. So don't get that the why two programs are there. So one is in assembly and one is in C programming. So the logic is same. That is first is that the initialization. Sorry, it goes ahead. Initialization, writing the this command and giving the data to the LCD. So the steps are same, only the syntax and way of writing, that the curly brackets and in inbuilt functions. So that is the different one. So once we will complete this the assembly one, so afterwards we will start the this C also, so that you will not get confused in both one. So, and this one is a very important slide for you, is that, so in this, which character or which number or which symbol you want to display on the LCD. So directly we cannot, or that machine is also not getting that key A the user has pressed, or A user want to display on the LCD. So for that respective, it's a ASCII code or the binary we supposed to pass it on, because as we have seen in yesterday's that circuit diagram, so 8 data lines are there for the LCD display, and through which that the 8051 it is connected to the LCD display, and we have to give the command through 8051. So for that, what command has to be give, or that, because in code we are just writing the A B C D or 1 2 3 4. So that is to be get converted into the respective, it's a binary. So in this table, the respective decimal for that respective binary, for that respective octal, for that respective hex, and as well as the ASCII code is also given. So as long as the our learning period is there of your life, so this chart it should be with you, because the communication, it may be related to communication, or it may be interface with the hardware, the software. So this chart consists of all that data. So this is very important for the sake of this converting our local language into the machine language. So this one is also very important chart for you. This. And then afterwards we will go for the actual simulation, how we can do it. Now the simulation, it is the part of that, the actually the physical hardware as well as the software, but here we are using the kill software and Proteus software for simulation. Now you will ask me why two softwares are there, because the actual the matrix keypad or the LCD display or the stepper motor, that is not possible in the kill to just display visually, but that the same we can get it in the Proteus software. So those who are aware, so they might be knowing. So for that sake, we are going to use the Proteus software. How to use the Proteus software, the one session we have conducted on that. So in that we are going to simulate this one. but the software required for that, so that we are going to be execute through the kill. That is, when you are running the writing the code in the kill, you are running the code in the kill, one hex file is going to be generated, and that hex file, that is executable file, so that we are giving to this particular Proteus software for the simulation. The circuit diagram, whatever we have seen yesterday, so that circuit diagram we are going to build in Proteus, and the input for that, that is the software that we are giving the hex file, which is going to be generated through the kill software. So in front of you only, just I am also doing the same thing once again. So you supposed to just recall that the steps, you have to revise the steps which are used for this particular running the kill software as well as the Proteus software. So this is what the initially kill software is open. The code is already we have seen yesterday. So this code I am going to just copy paste over there. But what are the steps? So this will be a brush up to you. So first step is that it starts from the project. So firstly, I'm just doing this all. You just if you want, you can again read note down those might be the absent for that session, so you can just get it down, or you can see the video afterwards and you can repeat it once again. So project, new project. So anywhere you can just do it this one. So I will for my sake use the respective folder. On the desktop only I have prepared the folder for that, LCD 051. So already once I have tried over here, so now I am giving the name LCD 3. The extension is UV2. It is a kill version 3, so extension is UV2. In that way it is there. So if you are using the kill version 5, so there it will be UV4. In that way it is there. So project, it is, I'm going to save. Afterwards it is asking for that the which controller you are going to use. Now one precaution we supposed to take, that the whatever the in kill you are using the processor, the same processor you have to use in the Proteus. So that care we supposed to take. So for that whatever they are using normally, so Atmel 8089C51, like that the number is, yes, this one. So the configuration you can see here is it is the 24 megahertz, that is the crystal frequency, which, but we are using that 12, so that we can change it. How to change it, that I will tell. The other things are the same: 6 interrupts, 2 priority, UART, 4K ROM, and 128 byte RAM. The other things are the same. So this we will choose here. So you also just note down which processor controller has to be choose from this one, that is 8089C51. If may not be visible to you, so that's why I am just uttering this one. And okay, copy, here we have to click on no. So that is the first step, it is happened. Next step, right click on target 1, options for target, and from here you can just replace this one as a 12 megahertz. Got it? And what the other two changes we supposed to do in this window? So one is this one, that is the crystal, and other is the this output. So here we have to make it this tick mark. So what is this tick mark? That is create hex file. So that is to be made tick mark, and then okay. This is the step number 2. Third step is that we have to write the code, that is file new. So this new window will get open. So in this we have to write the code. So the same code, this one, I'm just copy down. So this is what the code I have written. Now save it. Here is that the save. So it is again asking that where to save. So in the normally in the same folder we supposed to save it here, but the extension we supposed to give that the ASM LCD3 dot ASM. Here in that way we supposed to write the extension, because here no such extension it has been by default comes. So LCD3 dot ASM. So save. Now it is getting the colorized and it is going to be checked that the syntax and all that. Now once again save. Now linking of this project with this file or this code. How to do that? Anyone is remembering? Is it? So right click on this source group 1, whatever this sub branch is there for that target one, and in that add files. Add files. So it will ask you which file you supposed to add over here. So we have to give the path of this particular file code. So where we have stored that the same folder over here in the desktop LCD1. Here the extension all files we have to choose so that it will show that, and LCD3. So LCD3.asm, this is the file it comes here. So now I will once just click it. It gets added. Now I have to close this. So how we got the confirmation? So here the plus sign has came, and if you are clicking on that, so you will get the LCD3.asm. This file is been getting added. So now the next part already we have seen in the many of the sessions. So once save, we have to check for the error. So translate current file. So it is just giving the 0 errors, means already I have removed the bugs and all that. So that's why it is not giving any logical as well as the syntaxial error. Then build target. So build target is also done, and rebuild for all the target files. So the third one also. So all these three symbols we supposed to just click. Now it is showing the 0 errors. Now it is the time for just generating the or run the program. So for that the steps is, first we have to start the debugging. So start the next step, this one, debugging. So here we have to click on OK, as this is the evaluation version. So that's why this window came. Once the debugging is started, so you can run the program. You can run the program. So here the shortcut is also available, or in F5 is also the shortcut key. So by just pressing the F5 key, you can run this particular code. So when it is going to be clicked, so here down, just see the cursor. So here you can observe the time is going to be elapsed. That is, the simulation has been started. So you can just check the output. Now where to see the output for such LCD display? Is it? So as if you are remembering yesterday's diagram, so I will open that one is also here, so that parallelly we supposed to just check out that. So this one, I will make it zoom so that it will be clear. So port 1 and port 2, it has been used in this. Correct. So just look at this particular code also. I will open the port 1, which is not showing anything, and port 2. So here also it is just showing the only one state. So this is actually what the exactly the all the data whatever we have sent, so that is been displayed, and it is the last step. Once again I will just run it, but we cannot see from this the port 1 and port 2 what the data has been sent, and how we can judge that what data we have sent. So for that sake we are going to use the Proteus software. So I am just minimizing this one, and I am just starting the Proteus software. So Proteus 8 link is also available on your study material page, so you can just download it and you can install those who are having the computers or the laptops at home. Now in this Proteus, the steps, so in the earlier session also you might be written, but once again just I am telling that it starts with that the new project. So in that new project we have to get it that the name again here. So it is not compulsory, but I am just having a habit of the same name we supposed to give for the whatever we have given in the kill. So I am giving here that the LC, what it is written, LCD3. The extension it automatically comes, that is the PDSPRJ. So that is by default it comes, and path also we supposed to remember. So it is again not compulsory to put in the same folder, but that will be the a good habit to just having all the files in a one folder related to our this project. So I will just make that path, browse, desktop, and what was that folder, LCD. So here just select this path. So in that path, this PDSPRJ. So what it mean, you just find it out, because every extension is having the some meaning and some expansion also. So you can just check it out. Now the new project next. Now here, do not create a schematic. That is actually, if you are aware of, the Proteus software is used for the PCB design and PCB preparation also. That is the for that image and all that. So right now we don't we are not going to just check it out. So here, do not create a schematic. Next. So here, do not create a PCB layout, so that we actually don't want. So just let me check it out. So here, create a schematic from the template. So okay, let us see. Here also no, here also no. Now here we have to select this one, that is the what firmware you are going to use, because we are going to use this the particular 8051 based. So family is 8051, but in that family which controller you are going to use, so that is to be choose from here. So we have chosen in that kill software 89C51, so that we supposed to check it out here. So that is very important in this case. Then next and finish. So schematic is also needed, or what? I am supposed to just check it out. I hope this schematic default, I'm just checking. These two, we have to get it tick mark. So let us see what error it gives. So it don't have the given the error. So these two only we have to give the tick mark. So it is just doing automatically the source code and the schematic capture. So schematic is nothing but this one. This what we can say, the canvas is ready for the connection. So that schematic we supposed to make it tick mark. That is I want. So automatically this, if you are not visible, so here 89C51. So that already been, it is put on the this canvas. So that also we can see here. Now what are the other components that we supposed to put over here? So for that the diagram should be there with you. So we want this LCD. So as I told earlier also, ki the left side, this connections, it is must, it is required for whenever you are doing actually physically. But for the simulation purpose, the power supply and all, it is the all virtual here. So only the right hand side. So this part we supposed to just make it happen in this particular connections. So that care we supposed to just take it over here. So let us see. So how to bring or how to add the new components in this. So here, see the cursor P. So if you are clicking on the P, so one more window it will open. So here, what you want, that LCD display, 16 by 2 LCD display. So it is the list, it is coming over here. So LCD display, it is 16 by 2 like this. 16 by 2 like this, if you are giving. So it is just filtering the correctly one, and from that I will choose this one. So this is what the pinout diagram for that respective LCD display, and that I will choose. So make it double click, so it gets added in our component list. So make it close. Now as it is been, see here, click on this, click on this, and if you are just taking the cursor on the canvas, it is just showing. And once the click, so for few seconds we supposed to wait. And it is coming on the screen. So few seconds we supposed to wait. So why that waiting is required, so I actually don't know, but this is required. So just 1 minute. Okay, sorry for the interrupt. Some other responsibilities are also there, so that's why I supposed to attend that. Okay, so where we were. Hmm. So we have put that the LCD component on the screen. Now we have to just check out the circuit diagram, and accordingly we supposed to make the connections over here. What is this? Here. So D0, it is connected to P1.0. D0. So here also how to connect. So just take this pencil type of this one. So click once or here, not on that. Why it is doing like this? We'll just take it out, this one, and here once the red spot you can see, make it click. I will make it zoom a little bit. Similarly, all we have to get it connect. Okay. So in this way we're supposed to make the all the connections. So this is the data lines I have connected. Now the control lines. RS P2.0. Where is the RS? No, I'm supposed to make it RS. Just click it here, click it here, and connect to that P2.0. In this way we're supposed to do it. RW, just click it here, click it here, click it here, and click it here. In this way, enable P22, because in the code also respective this P22 or the enable line is connected, so that should match. Otherwise there we have written the P2.3, clear P2.3, and here we are using P2.2, so that will not match and that will not work, and it will not give the as per our expectation the result. So once this is done, the remaining part, that is the VCC and the VDD, so that also we supposed to give over here. So for that again we have to search for the component. So right click on this schematic, place component, not component, it is a terminal. So here it is the terminal. So from that so this is also very important. I'll just note it down the steps how to add any component or the device in this. So right click, from that this list will come, place this list in that terminal, and in that power and ground, that too we supposed to select. So power is symbol look like this one, whatever you are seeing on this screen. Click it, it will get place it. So which pin is connected to the this power? So it is VCC, and here VDD. Here the name it is given VDD. The ground, so I will just put it over here. So VSS is nothing but the ground. So in this way we're supposed to just give it the connections. Now according to me, just all this right hand side the connections are been done. The VEE, that is also not needed actually. This LED, that is also not required for the simulation. Now I will save this particular project. So once the save, so again the same steps, that is debugging. we have to start the debug. So how to start the debug? The play, pause, stop, these buttons are here. That is the simulation. But before that, we're supposed to just see the debug. So here, start VSM debugging. So it is giving error to me here that unsupported version or letter required. Why this is so? Just let us see. Once the debug session is open, now run simulation. But before simulation, we supposed to give the input. That is the code we have to give it over here. So just go on this 8051 or 89C51 and just a second. I think we do this step before the this debug. So we have to stop this debug. Then only it is possible to just add this particular this window. It is going to be open. So in this,
I need extension, sir, for two.
just second.
I need extension.
What extension?
Extension board असं. पाहिजे. चालू करायला. नाही. ती बंदच राहते. फोटो पाठवले मी.
Okay. So once you click on that, this window will be get open. So in this, the program file. So this program file, it is asking for that the path and whatever the generated that hex file in kill, that we have to add over here. So let us see, just browse that. And here you can observe what the name we were given for that. So LCD3. So by that name, it is auto generated. So this path we supposed to give over here. Just select that file and open it. And okay. That step we forgot. Before the starting of that debugging, this should be done. Once it is done, so now start the debug. So it is giving some error, but let us see that what it is going to be shown. So if you have gone through the exactly the program, so what input or the data we have sent to that LCD display. So just look at this one. So this is what we got over here. That is the hello YouTube, and what next it is been showing that this curly bracket it is showing, don't know. We're supposed to just check it out in the code. I think here the same code we have copy pasted. So this is how it is going to be changed, or it will just show on the display. So let us, we will edit it. For that we have to stop the debugging, or first stop this running, then come out from that, automatically stopping the debug. And if you want to just display the some other text over here, so you supposed to change in the kill software, then run that software. So let us just check out over here. So one space it has been over here, so due to that it shows. So we will change this. First letters we will keep the same, but next we will change it. That is hello. So we like that we will do it. Here the debugging stop. Okay. Here also we stop the debug. then only we have to edit, then save, then check for error, build a target, then start the debug, and then run. Once the program is run, so hex file is modified now. So I will minimize this. I will stop it here now. Debug. Okay. What is this? Ground. Again, the click on that. Choose the same file. Click on OK. Save this. Start debugging. And click on run. Okay, so that the replaced the words, it is now showing on this one. So in this way, what the garbage characters also it is just showing in that. So where is the wrong that I supposed to just check it out? Only hello story we have given, that is the how many characters, that is 5 plus 5, but the additional it is a 16 total is the capacity of that. So that code also has to be add some required code, so that the once the I, that is the query I, it is ended, so next it should be go on blank. But this cursor, if you are looking at this 16 by 2, this is the second row, it is just going ahead. So that one by one, it is 16 times, it is just going in that, as this one is the 16 by 2 LCD display. So what about this, the additional for 5 characters? So that for that we supposed to just edit the there. But what my intention is behind that, that this is the what how we can interface the LCD. So when the actually physically we are going to perform this particular experiment, so definitely we will just rectify this code, and this practically, that is physically we are going to do the practical. So this is what the LCD can be. Now it is going goes on erasing also. So that is the clearing also, because the loop we have given in the program. So this is what it is going to be. For second line also it is going to be erase, even though there is nothing, but that cursor will just go on erasing that one, and again it is going to be stopped over there. So this is how the LCD interfacing with 8051 we can say, that is how it is going to be work. So now what is your duty is that to just uh, once again go through this particular video, because this video we are going to just upload on in your that study material sheet, plus the diagram, and those who are having that respective laptops and all that, so you can do this respective simulation at your home, so that once it will go under your hand, so then only you will get the confidence and how it is going to be work, or how, what is that code respective for what purpose. As I said here, that 5 extra characters it is showing, but it should not show that character. So for that, what the modification has to be do in that code, so that also we supposed to just check it out. So once you got the logic, so definitely you will get that one also. So for today's session, it is this one. So I hope that you got this the simulation part here. So we will have stop over here. So all these documents I will share it, so just go through it, and now you can just put your attendance, and you can leave for this session and go for the next session. So if any doubt is there here, so it is still 3 minutes are there, so you can free to ask here. I hope you all of you has written the steps, okay, how to do the exactly simulation, because in the same way we supposed to go for the other thing, that is the stepper motor and the matrix keypad and all other things also we supposed to see in the same way. In last unit we have gone through that the buzzer and the LED. So that experiment also, with the help of this Proteus, we can simulate. So you can just check it out on the internet, or you can do it. So don't forget, many of the students are forgetting to put their attendance in the chat box. And afterwards, when we are putting the absent numbers, then they are telling, "Sir, can I show the snapshot and all that?" So don't miss that. Compulsory, just put in the chat box your name, roll number. We are also just checking from one or two sites, but in that also sometimes it gets mismatching. So don't give chance to that mismatching in this. So you can now put your attendance and can leave the session. Thank you.